Hey everybody, this is Larry. This is day 29th of the July Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, other problems. And if you have questions, feel free to come ask. Uh, if you have the intention of learning, then I'm patient with that as long as I'm around. I am traveling a little bit in San Diego this week, so sometimes I'm a little bit slow, but there are a lot of smart people there. So on Discord. So we'll figure it out and have different visualization and so forth. Some problems are really hard. Like yesterday's problem was a little bit tricky and definitely hard to get the right visualization. But and I think it's probably my bad that I am able to jump ahead because a lot of it is experience and kind of seeing the patterns and then figure it out. So if you do struggle with problems like that, definitely just do a lot more practice. But I would also say, like, if you feel like you spend a good amount of time and still not get it, that's okay. Work on other problems and then come back later. Sometimes your mind will figure it out, or you maybe just missing some gaps that later on it makes sense, right? Yeah, just come back to it, leave it behind, and play around with it. Anyway, a little bit of spiel aside, today's problem is going to be 0, 1 matrix. Let's take a look. What does that mean? Given an m by n matrix, return the distance of the nearest 0 point each cell. This is between two adjacent cells, 1. Okay. So one thing that I always, let's see. This is a graph problem. When you see the distance, it's probably the shortest distance, and nearest is probably going to give you that hint. And the naive thing to do is going, for every 0, do a breadth first search or some kind of shortest path distance type thing. And depending on the m and the n and the whatever, it may be too slow. So, and I didn't even look at it. 10 to the 4th is going to be, 10 times n is going to be 10 to the 4th. So that's probably okay. But the other thing you can do is kind of just think about, okay, what would that look backwards, or maybe not backwards, but like a reverse type of thinking, right? And here, you can kind of play around the symmetry. Oh wait, nearest 0. I think I've said the other thing. I think I said nearest 1, but same idea, just in you can flip the 0 and the 1s. But yeah, so that means that for every, well, the obvious thing is that if it's already a 0, then the nearest 0 is just at itself, so it's 0, and then one distant away is going to be 1, right? So then and if you do it for each cell, where you do a breakfast on each cell, it's going to be too slow because it's n squared. Because at worst, let's say you have 1 0 at the corner, then everything is going to be, you look at each cell. For each cell, you can look at every other cell, and that's going to be n squared. When I say n squared in this case, it's actually where n is the number of cells and not just m, not the n that they give you. So sorry for that confusion. So if you want to say that, it could be m squared times n squared if you want to give it in this notation. So then the thing immediately after that is kind of just look at it backwards, right? For each, or play around with that idea of doing a multi-source thing where, okay, so the distance between 0 and this, for each cell, you think about, okay, for each cell, the closest 0, how do you get to it, right? Well, the opposite of it is the truth, because there is a symmetry for this problem, meaning that for this corner, for example, in cell 0, 0, the distance between them are symmetric, right? So that means that you can start from a 0 with the distance of 0, and then kind of do a breadth first search going out. And from that, you can kind of figure out how to generalize it to a multi-source thing, because you can, I think that's the general idea. You can also think about it as kind of, maybe another way to think about it is kind of a frontier type thing, where, okay, you start at the zeros and you slowly, so maybe another way to visualize that, and this is something that I try to do a lot, is try to figure out a different visualization, even though I am confident what I said is true, though maybe not as clearly. But having a different model just allows you to kind of prove to yourself you're right as much as you can. And for the frontier part is that, okay, let's, you could think about things as a time step maybe, or something like that, where, okay, we start with all the cells that are 0 distance away from zeros, which means obviously the zeros. And then next iteration, what are the cells that are 1 step away from 0? What are the cells that are 2 steps away from 0, and so forth? So these are kind of things that I'm thinking about and working through when I'm looking into a problem. And I know that I'm a couple of minutes in, and if this was a contest, I probably would have just jumped right into it and probably get in a couple of minutes, to be honest. But that's basically the idea that I got. So let's get started. So let's just do a simple breadth first search. So we have a queue. Is you go to let's just say deck in Python, and then yeah. So now we kick it off with what are we returning? Okay, so let's just say we have an answer is equal to some infinity times. I'm doing this a little bit in weird order. My bad about that. Let's set up the rows, let's set up the columns, and then here we do a very normal initialization of the matrix, and then we try to figure out, start with the zeros, right? So yeah, let's do from for each cell, if matrix y is 0, 0, then this is our initial condition. I'm just checking to see where the inputs are zeros or strings of zeros, because sometimes they're a little bit weird, but that's okay. And here, let's have a helper function called enqueue. I don't do this all the time, but mostly because I'm lazy, but I think this is okay. D for distance, so then here you would add x, y is equal to d, and also q dot append x, y, d, right? Is that okay? Yeah, I think that's okay. So yeah, so in this case, we want to enqueue x, y at a distance of 0, right? And then this is just becomes normal breadth first search. So while q is equal to 0, then yeah, and this is standard stuff. I don't want to get into it too much if you're a beginner, and I apologize for that, but this is just a simple way, and I'll explain this part slightly a little bit later. But so it might not make sense for now. But you also see me do this a lot, so yeah, so yeah, in this case now we DQ have x, y, d is equal to this, and then this is just standard breadth first search stuff, to be honest. Because and just keeping it in bounds, and I still make mistakes here, to be honest, but I have done this probably too many times now. Like if you wonder why I'm able to kind of just go by very quickly, I probably have done breadth first search or depth first, or like these graph EEPROMs maybe 1,000 times, to be honest. Like yeah. Yeah, like literally 1,000 times. Sorry, like someone just texted me and I got a little confused. But anyway, okay. So while this is, I didn't even set infinity. I think I was going to, and then I realized I didn't set the other ones as well. I get comments a bit. Actually, I get a bit of comments that why do I use this for infinity instead of math dot for what was it called? Full dot infinity. I think it's just a habit, maybe not a great habit even. Maybe I need to be a better pattern about this. But the reason is because I've aided during a contest once because this is int and this is float. Way often it doesn't matter, but sometimes it comes up and you just be very sad for way too long otherwise, right? So yeah, and this is if it's infinity, because it's breadth first search. Anytime it's not, it's basically is done, right? So in that case, we want to enqueue nx, ny, d plus 1, and then that's pretty much it. At the very end, we return answer, and every element should be set. And there we go. Let's put in this other test case as well with, oh, there you go. Yeah, so this looks good. Am I confident about this? Probably. M and N is equal to 1. There's at least 1, 0. Yeah, these are the edge cases that I would think about. So I think we're good. Let's give it a submit. I mean, I might still have a typo, but it's late and I'm tired, so it's a little bit YOLO today. Okay, so it looks good. This is just standard for search. So we look at each cell once here, so that's going to be M times N or row times column. For here, every item gets pushed on the queue once, and we only look at 4 directions, and everything gets in-queued and dequeued once. So that means that, yeah, it's going to be linear time, where linear is equal to row times column, which is the size of the input. So that is the time and also space, because because this loops execute linear number of times, because as I said, every queue gets popped in once and pushed out once. Yeah, that wording is a little bit weird, but it's still true. Yeah, in terms of space, obviously the answer, which is the size of the output, which is the lower bound, because that's the size of the output, it's going to be linear again, which is rows times columns. That's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe, and join me in Discord. Again, if you have questions, let me know instead of, I don't know. I feel like recently I've gotten a couple of trolls lately who, instead of trying to improve themselves, they make comments about my explanations, which is fine. Sometimes, like sometimes I'm just in a rush or something like that, and it happens. But you know, instead of, like, if you want to be better, ask questions that will help you be better. It's very easy for me to notice that you're not asking those questions, and I will just ignore you. Anyway, I hope that's fair. Stay good, stay healthy, to good mental health, and I will see you later. Bye bye.